Hi, this is Prashant Bharadwaj. Welcome back to this segment on network methodology in project management. We will focus on the activity on node type of network, and in this segment we will focus on the critical path method, CPM. And in the next segment I will teach you how to address PERT, P-E-R-T. In the next segment, we will discuss the other network methodology called Program Evaluation and Review Technique, or PERT. Now, before I even get into the network methodology, let us spend a minute on the Gantt chart. Here is an example of a Gantt chart for servicing a Delta airline jet. This is from the time the plane lands to the time that the plane takes off or is ready for boarding. What are the activities that occur and how long does it take? So as you can see in this Gantt chart, the horizontal axis is time. So in this case it is in minutes. Right away you can see that it takes from the time it lands to the time it is ready for boarding, it takes approximately 38 minutes. Okay. Now if you look at this, you can see that as soon as the plane lands, within a minute, you can start deplaning, offloading the containers, pumping fuel, offloading the container, servicing the main cabin door. The lavatory servicing itself we can start a little later, and you can also see that is the longest activity. If you look at aircraft check, that takes this long. So if you look at this bar, it starts around 21 and ends around 31. So we know that this activity takes 10 minutes approximately. Whereas pumping fuel takes approximately 25 minutes. Deplaning takes approximately 7 minutes. Few other things you can find out from this Gantt chart. Deplaning, baggage claim, pumping fuel, offloading container, all these activities can be done concurrently. So you can also see that some of the activities have to wait for other activities to be completed. The Gantt chart, however, is limited. It is not easy with the Gantt chart, especially if this number of activities increases to 40, 50, or even hundreds of activities. It is difficult for us to see which are the activities that are done concurrently, sequentially, and so on. Also, I cannot easily make decisions, such as if I have the same crew which is cleaning the cabin as well as servicing the lavatories, I cannot see what is the impact of missing one person out of the 6 people that are supposed to be in this crew. Or if one of the activities is taking longer than expected, how can I reallocate the resources? Those type of questions cannot be answered easily in the Gantt chart. Also, I cannot say what happens if a particular activity takes a little longer than expected. What is the impact of subsequent activities? These type of questions are going to be answered in the network methodology. So let's get into it. Like I have said, there are 2 methods, CPM and PERT, when we talk about network techniques. They consider the precedence relationships and the task interdependencies. Both were developed in 1950s. Just to give you some historic perspective, the CPM, or the critical path method, was developed by the company DuPont for maintenance activities in their chemical plants way back in 1957. whereas the PERT method was almost concurrently developed in 1958 by the consulting firm Booz Allen and Hamilton, and it was developed for the US Navy, which was developing the first intercontinental ballistic missile, the Polaris, in 1958. What is the difference between CPM and PERT? Essentially, they are the same, except for one key difference. CPM uses what we call as deterministic time estimates for tasks. So if one of my tasks is excavation and foundation for the building, in CPM I would say that particular activity of excavation and foundation will take 20 days. Whereas in PERT, for the same activity, I will have three different estimates. An optimistic estimate, which will be less than 20 days. So if everything goes well perfectly, then you may complete that particular task or activity in 16 days. Most likely is the second estimate, which may take 21 days. The third estimate is the pessimistic estimate. This is when Murphy's law plays a role. Everything that can go wrong will go wrong. So if that happens, then the excavation and foundation may take 30 days. So you have three estimates here. 16 is the optimistic, 21 is the most likely, and 30 is the pessimistic. That is what PERT does. CPM just says it will take 20 days. That is deterministic, whereas the three different time estimates based on PERT is probabilistic. In the next segment, I will show you how these three time estimates can be used to come up with combine these three into one time estimate and use the same methodology as CPM, which we will discuss in this segment, and subsequent analysis will be slightly different in PERT. So let us focus on CPM currently. Always it's good to work with an example. So let's start working with this simple example where you have a paper manufacturing company. All these 8 activities are involved, which have been labeled as A through H for convenience. So A is build internal components, B is modify a roof and floor, and so on. So there are 8 activities. The next column gives you the immediate predecessors. So like you see here, activities A and B do not have any immediate predecessors. So right before A and B can be started, nothing need to be completed. However, right before C can be started, its immediate predecessor is A. D, before you can start activity D, its immediate predecessors are A and B. So you can see the immediate predecessors for all the 8 activities, and among those 8, the first 2 do not have any immediate predecessors. They can be started right away at time 0 of the project. Now the last column tells us how long it takes for each activity if they are done independently. So activity A takes 2 weeks, B takes 3 weeks, and so on. Now, if you are a project manager, the first question that will come to your mind is how long will this project take to complete? When you are bidding for the project or negotiating with the customer, the first question is how long will the project take? So you got to have a good idea. Typically in my class, when I ask the students, what do you think? How long will this project take? Almost half the students will tell me 2 plus 3 plus 2 plus 4 plus 4 plus 3 plus 5 plus 2. 25 weeks. Obviously that is not correct, right? And occasionally I have a couple of students who will say, okay, activities A and B can be completed, both of them, in 3 weeks. If you start today, at the end of 2 weeks, you'll be done with A. At the end of 3 weeks, you'll be not only done with A, but also with B. Now let's look at C. It cannot be started until A is completed, which can be completed in 2 weeks. So at the end of 2 plus 2, 4 weeks, I can be done with A, B, and C. Got it? Then let's look at D, which requires both A and B to be completed. So both A and B can be completed at the end of 3 weeks. So then you can start D, 3 plus 4, 7 weeks. So at the end of 7 weeks, I can be done with the first 4 activities, A, B, C, D. Now let's look at E and F. Both of them require C to be completed. So when was C completed? In 2 plus 2, 4 weeks. So at the end of the 4th week, I could have started both E and F. So what am I saying? 4 plus 4 is 8, 4 plus 3 is 7. So at the end of 8 weeks, I can be done with A, B, C, D, E, F. Then let's look at G. It has to have both D and E completed. When did I complete E? Only at the end of 8 weeks. So 8 plus 5, 13 weeks, I'll be done with G. Then I can start the last activity, H, and 13 plus 2, 15 weeks. In 15 weeks, I can complete this project. If you did not understand what I described in the last 2 minutes about how to calculate the time required to complete this project and came up with 15 weeks, I have 2 options for you. Go back and listen to it. The second option is better, forget about it. Why? Why am I saying that? Because if I increase the number of activities to 40 activities instead of 8, what I just did is humanly impossible unless you're a real genius. That is the reason we have the network methodology, which will make it much easier than the very cumbersome way in which I calculated how long it will take to complete this project and came up with 15 weeks. So that is the network methodology, which will make it simple for all of us to understand how long the project takes, as well as much more significant and useful information. This is how a network looks. This is a network. What is a network? It has a start, it has an end. It has a number of circles, number of arrows. Do you see a loose end in this? No. It is all closed. That is why it is called a network. But let's understand some terminology before we go any further. Activity is each one of these, A, B, C, D, so on. Nodes are circles. Arrows are arcs. That is why this methodology is known as activity on node, AON. So activity A is on this node. Node is the circle. Activity B is on this particular node. C is on this, so on. Now, what we just found out was that the project takes 15 weeks. That is not everything a project manager wants to know. That is just one of the pieces of information. Now let's look at something called earliest start, earliest finish, latest start, latest finish, and slack or float. We'll look at what is a critical activity, what is a non-critical activity. What is forward pass? What is backward pass? I will explain that to you in a second now. Here, the forward pass, I will go this way from start to finish and calculate earliest start, earliest finish, earliest start, earliest finish. So what does that mean? The earliest that I can start activity A, the earliest that I can start C, the earliest that I can finish F, the earliest I can finish B. Is that something useful as a project manager? Absolutely. If I am a construction manager, I would like to know when I should be getting my plumbers, when I should be getting my electricians, when I should be getting my framing people. Unless the excavation and foundation is completed, the framing people cannot do much. Unless the entire house is completed, the painters cannot do much, especially the finishing touch. So it is important for me to know what is the earliest time that I can start painting. What is the earliest time my electrical work will be finished. On the same token, you also want to know what is the latest time you can finish the painting work and still complete the project on time. What is the latest I can delay? What is the earliest I can start? Is there any flexibility that is slack? If the earliest time you can start is the same as the latest time that you can start, you have no flexibility, you have no slack. But if the earliest time that you can start is week number 5, or the latest time that you can start is week number 7, you know that you have some flexibility or slack. These things will become more clear now when we calculate these numbers: earliest start, earliest finish, latest start, latest finish. In the forward pass, that is going from start to finish, we will calculate the top 2 numbers: earliest start, earliest finish. Going on the backward pass, we will calculate the latest start and the latest finish. And then we'll calculate the slack and determine the critical and non-critical activities. So this is the notation we'll be using. So each of these nodes or circles will represent a particular activity, the duration time, how long it takes, the earliest start, earliest finish, latest start. So with this, let's go here and calculate these particular numbers. So like I said, first we'll go in the forward pass to identify earliest start and earliest finish. What is the earliest I can start activity A? No immediate predecessors. This is the first activity. So I can start activity A right away at time 0. If that is the case, what is the earliest time I can finish it? How long does it take to complete activity A? 2 time periods. So the earliest time I can finish activity A is 2. Same thing with B. You can start it immediately and it takes 3 weeks. So the earliest time I can finish is 3 weeks. Let's look at C. What is the earliest time I can start C? The earliest I can start C is the time that A is finished. What is the earliest I can finish A? 2. So at the end of week 2, you can start activity C. The earliest time you can finish is 4. 2 plus 2. D. Now D, when can you start earliest? What do you need to do? What do you need to look at to decide that? You gotta have A and B both completed. Look at these arrows. Both of them need to be completed. I am done with activity A at the end of second week. Can I start D at the end of second week? I hope all of you said no, because B is not done until the end of third week, and it is also a predecessor, an immediate predecessor of D. So the earliest I can start D is 3 weeks at the end of third week. So the earliest I can complete D is 7. 3 plus 4, 7. Clear? Okay. Now let's look at E. E is simple. How many immediate predecessors does E have? Only one, C. So all I have to look at is the earliest finish time of C. That can be the earliest start time of E. 4 plus 4, 8. Again, don't forget what these numbers are. These are the numbers that were on the table corresponding to the duration for each of these activities. A takes 2 weeks, B takes 3 weeks, C takes 2, E takes 4, and so on. Continuing with the earliest start and earliest finish. Let's look at F. Again simple. F has only one immediate predecessor. C, its earliest finish time is 4. So F's earliest start time is 4. Earliest finish time is 7. 4 plus 3, 7. G is again similar to D. It has two immediate predecessors. D is done at the end of 7, but I cannot start G at 7 because E is done only at the end of 8. So I'm taking the larger of these two numbers and then putting it there. In this example, I don't have any activity which has 3 immediate predecessors. So if I have 3 immediate predecessors for G, for example, I would look at 7, 8 as well as the third activity's earliest finish time. If that happened to be 12, then my earliest start time for G would be 12. But in this case, I have only 7 and 8 to deal with, 2 immediate predecessors, and their earliest finish times are 7 and 8. So if you're a formula-oriented person, earliest start time is equal to the maximum value of the earliest finish time of the activity's immediate predecessors. So you're taking the maximum value of 7 and 8, you're putting it here. Continuing, G earliest finish will be 8 plus 5, 13. Finally, H has two immediate predecessors, F and G. So F is done at 7, but H takes a lot more time to get started because it has to wait for G to be done also, which is at the end of 13. 13 plus 2, 15. That completes the earliest start and earliest finish. Now let's do the latest finish and latest start. Now I'm not going to go this way. I'm going to go this way. That is why it is called the backward pass. So in the backward pass, you do the finish time and subtract the activity time from the finish time to get the latest start time. Now, how long does the project take to be completed here? 15 weeks. We know that now. Because the earliest time H can be completed is end of 15 weeks, and once H is done, the project is done. So that has been established, 15 weeks. Now, what is the latest time you can finish H? Obviously, same, 15. What is the latest time you can start H if you have to complete it at the end of 15th week? 15 minus 2, 13. Got it? So you may wonder, there's no difference between this and this. We'll get to that. So the latest time you can start H is 13. Okay? Now, if that is the case, both F and G have to be completed before H starts, right? If the latest time that you can start H is 13, what is the latest time you can complete F and G? If you want, you can extend both of these all the way up to week number 13. Because the latest time you have to start H is 13, it doesn't matter even if this is done at 13, this is done at 13, it's not going to affect anything negatively, right? So 13 and 13 are the latest finish times for F and G because the latest start time of their succeeding activity H is 13. So G 13 minus 5, 8 is the latest start time. 13 minus 3 is 10. Now you will see that these have the same earliest start, latest start, earliest finish, latest finish. Same thing with G, but that did not happen with F. You will see some of the activities which will be like F, some will be like G and H. Let's continue backwards. E, which activity is dependent on E? G only. So let's look at now forget about the top two numbers, please. When you're going back, don't look at the top two, the earliest start time and earliest finish time. Just forget about the top two numbers for now. So if you look at 8 is the latest finish time. That is also the latest. 8 is the latest start time and 8 is also the latest finish time of E. So this has to be 4. 8 is also the latest finish time of D. 8 minus 4 is 4. Now this is the first time C. If you look at this, it is a little tricky. Which are the activities that are dependent on C? Both E and F. So you better finish C without affecting both E and F. What is the latest time you can start F? 10. Does that mean you can finish C at the end of 10 weeks? No. Why? Because the latest time you can start E is 4. So now you're taking the minimum value of the latest start time of the immediate successors. Let me repeat. If you are a formula person, the latest finish time of an activity is equal to the minimum value of the latest start time of this activity's immediate successors. So you have 4 and 10. The minimum number is 4. 4 minus 2 is the latest start time for C. Let's do B. B, only activity dependent on B is D. So very simple. Take this 4. That will be the latest start. 4 minus 3, 1. What is dependent on A? C as well as D. So I have to take the minimum latest start time of C and D, which is 2 and 4. So that will be 2. 2 minus 2 is 0. Done. Now, if you are not clear, listen to this again one more time. Once you have done that, let's observe. Do you recall when I looked at the 4 paths in this particular network? It was ACFH, ACEGH, ADGH, BDGH. Which was the critical path? ACEGH. Do you see something common in these 5 activities which is not in the other 3 activities? Absolutely. 02, 02, 24, 24, 13, 15, 13, 15. Whereas F, D and B 4, 7, 10, 13, 03, 14, 3, 7, 4, 8. So the point I'm trying to make is in activity A, the earliest start is 0, the latest start is 0. Earliest finish is 2, latest finish is 2. Activity G, same thing. Earliest and latest start are both 8. Earliest and latest finish are 13. H, E, C. So here there is no slack. If I delay activity F by 1 week, instead of starting it at 4, I started at the end of 5th week. Is there a problem? No, because the latest start time is 10. If I start activity F 3 weeks later, instead of end of week 4, you started week 7, end of week 7, no problem still. The latest start time is 10. Instead of taking 3 weeks, if I take 8 weeks for F, will that be a problem? Most likely not, because if I take 8 weeks, I can still start at 4, be done at 12, and the latest finish time is 13. Get the point? So there is a lot of flexibility here for F. There is some flexibility for B and D, just one week. But is there any flexibility for A, C, E, G, and H? Absolutely nothing. That is why these are the critical activities, and you always find in a project that there is a set of critical activities which form a critical path. That is the reason that you have the name critical path method for this particular methodology. So what we have found out so far is what is the earliest you can start an activity, what is the earliest you can finish, the latest you can start, latest you can finish, what are the critical activities, what are the non-critical activities, and what is the amount of flexibility or slack you have in each of these particular non-critical activities. So if I ask you a question like, is it okay to start activity F in the 8th week? No problem. The latest start time is what you would look at, 10. If I ask you, is it okay to complete activity F on the 11th week? What number would you look at? I asked you, is it okay to complete F at the end of the 11th week? No problem. You're looking at latest finish time, 13. Is it possible to be done with F in week number 3? The answer is no. Because look at the earliest start and earliest finish here. Is it possible to start activity F in the 3rd week? Nope. The earliest start time is 4. Is it possible to complete activity B by the 2nd week? No. The earliest finish is 3. All these types of questions can be easily answered once we have this. So if this is clear, let me take you back to the PowerPoint. So we basically calculated all this: earliest start, earliest finish, latest start, latest finish. The slack is the activity on the critical path or not. So what I showed you on the diagram is tabulated nicely here. So this method is known as the critical path method, where we have found out how to draw the network. Subsequently, we have determined the earliest start, earliest finish, latest start, latest finish. For the top 2 numbers, we went on the forward pass. For the bottom 2 numbers, we went in the backward pass. Then we found out what were the critical activities. That is nicely shown here. And what are the non-critical activities? What is the amount of flexibility we have on the non-critical activities? And in addition, we can ask specific questions and answer what is the earliest we can start, earliest we can finish, latest we can start, latest we can finish. I hope it is clear. If not, I recommend that you go back and listen to this or view this presentation again.